students. I hope you all are doing good. In the previous lecture, we have learned set operations. Now we are going to start the exercise. Now we have a question given the sets a is equals x such that x is a positive even integer less than 10. Set a in tabular form will be 2, 4, 6, 8. Then we have set b which is equals to x such that x is a positive odd integer less than 10. So set b in tabular form will be 1, 3, 5, 7, 9 are the subsets of the universal set. And universal set is defined as x such that x is a positive integer less than 10. So universal set in tabular form will be written as 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now we have to find out A union B complement, A complement intersection B, A complement intersection B complement, A symmetric difference B, A difference B complement, A complement symmetric difference B, A complement intersection B whole complement. And also we have to draw the Venn diagrams of question number 9 from question number 9 to question number 15. Okay, let us start solving. Universal set was given as numbers starting from 1 to 9. Set A 2, 4, 6, 8 and set B 1, 3, 5, 7, 9. Let us start question number 9. A union B complement. We have to find out the complement of A. We have to find out the union of set A with B complement. When finding the union of two sets, we just write down all the elements that belongs to both the sets. But same elements are written just once. So when finding A union B complement, we will find B complement first. Find B complement. B complement is equals to universal set minus set B. Universal set is defined as 1, 2, 3, 4, 5, 6, 7, 8, 9 minus set B is defined as 1, 3, 5, 7 and 9. Just cancel out the common elements and write down the remaining elements of universal set. This is the set B complement. Now we are finding the union of set A with B complement. We are finding A union B complement, so we will write set A first, 2, 4, 6, 8 union, and then the set of B complement, which we have found out in previous step. Now we are going to find the union. Union means we have to write all the elements that belongs to both the set, but the same elements are written just once. So our answer will be 2, 4, 6, 8. Now for making the Venn diagram. The steps that are involved in making a Venn diagram. The first one is draw the rectangle which represents the universal set. Second step, draw the circles also. Here we can see that set A and set B are disjoint set, means there is no common element between set A and set B, so we are making disjoint circles. Okay, there is no common element between these two circles. Now the fourth step, shading. Here our answer has 2, 4, 6 and 8. So we will only shade the part which contains these elements. So the part which is shaded in this diagram will be the first circle. It means we will shade this circle because this is the part which contains the elements that belongs to our answer. Okay. Next part. So this was our part 9. Part 10 and part 11 you have to solve it yourself in the same way as we have done this part. Now we have question number 12. Question number 12 is A symmetric difference set B. Universal set is given to us, set A is given to us, and set B is given to us. Now we have to find the symmetric difference. To find symmetric difference of set A and set B, we use this formula. Symmetric difference of two sets is equals union of those sets, intersection of those sets, and then find the difference of the union and the intersection. So to find A symmetric difference B, we will first find out A union B. First write set A and then write set B, and A union B will be 1, 2, 3, 4, 5, 6, 7, 8 and 9. Then we are going to find A intersection B. We are finding A intersection B, so we will write set A first, then use the symbol of intersection here, and then set B. When finding the intersection, we just write down the common elements, only the common elements. So set A intersection B will be the null set. Please keep in mind that we are going to use the symbol for intersection here, not the symbol for union. Okay, we are going to use the symbol for intersection here. Okay, A intersection B is just the null set. Now we are going to find the difference of A union B and A intersection B. A union B is set 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, difference A intersection B. A intersection B is just the null set. Now we have to subtract the same elements and write down the remaining elements of first set only. So there are no common elements, so we will write down 1, 2, 3, 4, 5, 6, 7, 8 and 9. This is A symmetric difference B. Now the diagram. Draw a rectangle to represent universal set. Set A and set B are disjoint sets. They do not have common elements. So we will draw disjoint circles, or we can also draw overlapping circles, but the overlapped area will remain empty because we do not have any common element. Okay, then write the remaining elements of both the sets in the circles. Now the fourth step, shading. Here we can see that the set A symmetric difference B contains elements 1, 2, 3, 4, 5, 6, 7, 8, 9. So we will shade the part which contains these elements. So we will shade this part, the circle, the first circle, and also we will shade the second circle. But the overlapped area will not be shaded because according to the definition of symmetric difference, the symmetric difference of two set contains everything that does not belongs to the intersection. So we will shade both the circles, leaving the intersected area unshaded. Okay, moving to the next part. That was question number 12. Now question number 13. We have to find A difference B complement. So we have to find B complement first. You will find B complement in the same way as you have done before. B complement means universal set minus set B. So subtracting set B from the universal set, we will get elements 2, 4, 6 and 8. Now we have to find difference of set A and B complement. We know that when we are finding the difference, we just cancel out the common elements and write down the remaining elements of only first set, only the first set. So here 2, 4, 6, 8 all are common elements and all will be cancelled out. So we will left with nothing in our set. We will get a empty set. Now the diagram. Rectangle to represent universal set, set A and set B. We can also draw overlapping circles, but the overlapped area will be remain unshaded because we do not have common element. So we are going to draw disjoint circles. Here we have to shade the null set. Here we have to shade the empty area. So you can shade the area which is empty. Here you can see the empty area is the part which is outside both the circles. It means the rectangle, the remaining part of rectangle leaving both the circles. You can shade this part. Okay, leaving both the circles, you can shade this part. Because the answer is null set, it means we have to shade the part which is empty, and the part outside both the circles is the empty area, so we will shade it. Part 13 is done. We are going to start question number 14. A complement, symmetric difference, B complement. It means we have to find A complement first, in the same way as we have done for B complement. A complement means universal set minus set A. Write universal set first minus set A. All the same elements will be cancelled out, and the remaining elements of universal set will be written in the set of A complement. So we will have 1, 3, 5, 7 and 9. Now to find A complement, symmetric difference B, just write down the sets first. Set of A complement is 1, 3, 5, 7, 9. Symmetric difference set B also contains 1, 3, 5, 7, 9. Here we have two options. Either use the formula which we have learned, or we can find out symmetric difference directly. If we have to find just the symmetric difference, we will use the formula. If to find symmetric difference is a part of any question, we can solve it directly. Okay, to solve it directly, we just cancel out the similar elements and then write down the remaining elements of both the sets. The elements which are remaining in both the sets will be written. Here we can see all the elements of both the sets will be cancelled out. So we are left with only null set, empty set. To draw the Venn diagram, we have to draw rectangle, then the circles, write down the elements in the circle. Now we have to shade empty area, empty set. So as we have done in the previous example, the area which is outside the circles and inside the rectangle will be shaded. Okay, moving to the next part. Part 15. A complement intersection B, whole complement. We have to find the complement of A complement intersection B. It means we will first find A complement. The sets which are given to us are these: universal set which contains numbers from 1 to 9, set A which has 2, 4, 6, 8, set B which has 1, 3, 5, 7 and 9. Now we are finding A complement first. To find A complement intersection B whole complement, we have to subtract A complement intersection B from the universal set. To find the complement of A complement intersection B, we have to find universal set minus A complement intersection B. It means we are going to find this part first. Okay, we are going to solve A complement first. To find A complement, we have to subtract set A from universal set. Universal set minus set A will be, then A complement is equals to 1, 3, 5, 7 and 9. Now to find A complement intersection B, first write the set of A complement intersection set B. In intersection, we just write down the common elements. Here we can see both all 1, 3, 5, 7, 9 are common in both the sets. So our answer will have 1, 3, 5, 7, 9. This is the set of A complement intersection B. Now we are finding the whole complement of A complement intersection B. So we will subtract the set A complement intersection B from universal set. Write universal set first and the set in complement intersection B. Cancel out the common elements and write down the remaining elements. So A complement intersection B whole complement is equals to 4, 6 and 8. We will draw its Venn diagram in the same way as we have discussed for previous questions. Now we have another question. Let set A is equals 1, 2, 3, 4. Set B is equals 2, 4, 6 and 8. And we have to show that part 17, A symmetric difference B equals A union B minus A intersection B. Then we have part 18, A symmetric difference B equals A minus B, A difference B, union B difference A. And part 19, A difference B is equals A difference A intersection B. Now we are going to start part 17. Keep in mind, whenever we are solving a question which is like show that, we have to show that the left hand side is equals to the right hand side. So we will consider any one side first. Here we are taking left hand side first. Left hand side is A symmetric difference B, and we have learned how to find the symmetric difference. To find the symmetric difference, we just cancel out the same elements and write down the remaining elements of both the sets. Here 2 and 4 will be cancelled out and the remaining elements of first set will be 1 and 3 and remaining element of second set will be 6 and 8. So A symmetric difference will be 1, 3, 6 and 8. Here you can also use the formula. No, you cannot use the formula. You have to prove that formula. No? So first find A symmetric difference B directly, and then for right hand side you will solve this part. Taking right hand side, in right hand side we have A union B minus A intersection B. When finding A union B, we have to write all the elements that belongs to both the sets. But do not repeat the element. Here we can see 2 is same, 2 and 4 are same in both the sets, but we have written it just once. Now A intersection B. When finding the intersection, we just write down the common elements. So A intersection B is just 2 and 4. Now we have to find the difference of A union B and A intersection B. Set A union B is 1, 2, 3, 4, 6 and 8, and set A intersection B is just 2 and 4. We are finding the difference. In difference, we just cancel out the same elements and write down the remaining elements of first set. So we will write 1, 3, 6 and 8. Now we can see both the sides, left hand side and right hand side, have got the same set. It means we have shown or we have proved that the left hand side is equals to the right hand side. Part 18 you have to do it yourself. Now part 19. Again the question is show that. So we have to take left hand side and then right hand side. Taking left hand side, we have A difference B. To find A difference B, write set A first, difference set B. In difference, we just cancel out the common elements and write down the remaining element of first set only. So our set will have 1 and 3. This is our left hand side. Now solving right hand side. In right hand side we have set A minus A intersection B. So we have to find A intersection B first. In intersection we just write down the common elements. So A intersection B will be equals to 2 and 4. Now finding the difference of A intersection B and set A. Write set A first, difference A intersection B. Cancel out the common elements and the set will have only 1 and 3. Here we can see the left hand side and right hand side both are equal. It means we have proved. Now we have De Morgan's law. De Morgan's law for the set complementation. According to De Morgan's law, let U be the universal set containing sets A and set B. Then De Morgan's law is A union B whole complement is equals to A complement intersection B complement. Second part, A intersection B whole complement equals A complement union B complement. When we have union here and we are taking the whole complement, then both the sets have separate complement on each other and the operation will become the intersection. If we have intersection and we are taking the whole complement, then the sets will have their separate complements on them and the operation between them will become union. Let us take an example to prove the De Morgan's law. Let universal set is -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Set A we have -2, 2, 3, 4, 5 and set B we have 1, 3, 5, 8 and 9. Now we are going to prove the De Morgan's law. We are taking the first De Morgan law, A union B whole complement, which is equals to A complement intersection B complement. Whenever we have to prove an expression or equation, we have to solve it side by side. So we are considering left hand side first, which is equals to A union B whole complement. A union B whole complement means we have to find A union B first and then subtract the set from the universal set. So to find A union B, we will write set A first and then set B. In union, we just write down all the elements that belongs to both the sets. So A union B will be -2, 1, 2, 3, 4, 5, 8 and 9. Now to find the whole complement, we have to subtract A union B from universal set. So write down universal set first minus the set of A union B. Minus, or we are finding the difference, it means we will cancel out all the elements that are common to both the sets and write down the remaining elements of first set only. So common elements will be cancelled out and we are left with only -1, 0, 6, 7 and 10. This is our left hand side. Now taking the right hand side. Right hand side has A complement intersection B complement. We have to find the intersection of A complement and B complement. It means we should have A complement first and B complement. So finding A complement first, we have to subtract set A from the universal set. Universal set minus set A. Write down universal set first and then set A. All the common elements will be cancelled out and the remaining elements of first set will be written only. So A complement will be minus 1, 0, 1, 6, 7, 8, 9 and 10. B complement we have universal set minus set B. Subtracting the elements of set B from the universal set, we will get these elements. Now we have found out set A complement and set B complement. Now we are going to find their intersection. To find the intersection, we just write down the common element. So the common elements between both the sets are minus 1, 0, 6, 7 and 8. Here we can see our left hand side and right hand side both are equal. It means we have proved our De Morgan's law. Now take another example. Sets are the same as we have taken in previous example. Universal set is minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. The set A, same as the previous example, minus 2, 2, 3, 4, 5. Set B, 1, 3, 5, 8 and 9. Now we have to prove the second De Morgan law, which is equals to A intersection B whole complement equals A complement union B complement. We have to verify or we have to prove the law. It means we are taking side by side, taking left hand side first, which is equals to A intersection B whole complement. To find the complement of A intersection B, we have to find A intersection B first. To find A intersection B, we just write down the common elements of set A and set B, which is 3 and 5. Now finding the complement. To find the complement, we just subtract A intersection B from the universal set. Write universal set first, then the set A intersection B. Cancel out the common elements and write down the remaining elements of only the first set. We will get the left hand side. This is equals to 2, minus 1, 0, 1, 2, 4, 6, 7, 8, 9 and 10. Now taking the left hand side. A complement union B complement. Find A complement first, which is equals to universal set minus set A. Write universal set first minus then set A. Same elements will be cancelled out and we will have only minus 1, 0, 1, 6, 7, 8, 9 and 10. To find B complement, we will follow the same steps. B complement is minus 2, minus 1, 0, 2, 4, 6, 7 and 10. Now we will find the union of A complement and B complement. We will get 2, minus 1, 0, 1, 2, 4, 6, 7, 8, 9 and 10. In union, we write down all the elements that belongs to both the sets. But do not repeat the element. So here we can see our left hand side and right hand side both are equal. It means we have verified the law. Now exercise 1.2, question number 20, which you guys have to do yourself. Universal set is given to you, set A and set B are given to you. You have to verify De Morgan laws. It means you have to verify both the laws. Okay, you have to do it yourself in the same way as explained in example number 1 and example number 2. Good luck.